Hello friends, in this session we are going to understand interfacing of 8051 microcontroller with external memory. Let us go through the question for this. So question is interface 32 kilobytes of ROM and 16 kilobytes of RAM, both external memory, with 8051 microcontroller. Let us get into the solution of it. First let us understand how many address lines are required in order to interface these memories. So starting with the first one, the 16 kilobytes of RAM. So 16 kilobytes in the sense it is 2 to the power of 14. So 2 to the power of 14 in the sense we require 14 address lines in order to interface this RAM. 14 address lines, if we represent with respect to the 8051 addressing lines, then it is going to take the lines from A0 up to A13. The second one, 32 kilobytes of ROM. 32 kilobytes in the sense it is 2 to the power of 15. That means we require 15 address lines to address this memory location. So with respect to 8051, 15 in the sense it is going to have the value from A0 up to the A14. Total it forms 15 address lines. Now with respect to 8051, if we speak, so there are two ports in 8051 which we can use for address as well as for data lines. The first one is the port 0. The port 0 is going to have the lines AD0 to AD7, where this can act both as address line as well as data line, that is LSB 8 bits of the address lines. Then port 2 is A8 up to A15, that is exclusively address line. MSB part of the address it is going to form. So total, if we make combination of these two, so this can make a total address lines A0 up to A15. Total 16 address lines we can make use of. But as per our requirement, we require only up to A14, and remaining two will be remaining the last one A15 will be left blank. So now let us get into the diagrammatic realization or the block diagram realization of this memory interface. Here is the block diagram representation of the interfacing. So the first one, that is this block, is 8051 microcontroller, and here is the 16 KB of RAM. So this is RAM, and this is 32 kilobytes of ROM we are having, and in order to store the intermediary address we are going to have the latch which can store 8 bits of the address. Now let us first make a address line connection and the data line connection for the RAM, 16 kilobytes of RAM, and then we will move on to the 32 kilobytes of ROM. Now as per what we have observed, so in order to interface this 16 kilobytes of RAM, we require 14 address lines, and that will be from A0 up to A13 is the requirement. That many address lines we require. So here let us come back here. So A0 to A7 we can get it from this port 0, and continuation A8 to A13 we can get it from port 2, right? So first port 0, let us make it out. So port 0 can address both address lines as well as the data lines it consists of. So we must make the data line available for further usage. Therefore first we are going to latch the address to this latch, and then we are going to make out the further connection. So first AD0 to AD7 we are going to connect that to the latch, so that the address lines will be available further for the usage. So this is now only A0 up to A7 we are going to have, right? And whatever the remaining will become the data line, and data line is always 8-bit data line that we can connect to the RAM. So this will be D0 up to D7. Data line part is completed. Now continuation. Now let us make a connection of address line to the 16 kilobytes of RAM. So So A0 to A7 is required. So let us connect it. So this is A0 to A7 bus what we are having, right? So A0 up to A7 it is completed. Another bus A8 to A13 is required. So this is the bus having the address A8 to A13. So A8 up to A13. So as per what we have sorted out, so A8 to A0 to A13, now total address has been interfaced, address lines has been interfaced with the RAM. Now let us get into the ROM. So ROM requires how many address lines? So total 15 address lines, that is from A0 up to A14 is the requirement, right? So now what we are having, let us make the lower byte of the address first, that is A0 up to A7, and then in continuation we are having here A8 up to A13. So this is A8 up to A13 we have, and we require A14 also. So A14 is available for us. So I'll be taking that as an individual line. So A14, and I'll be connecting that to the ROM memory. Now A0 up to A14, now addressing the complete 32 kilobytes of memory. Now any data to be taken from the ROM, again we need to connect that to the data bus. So data bus we need to connect. So basic connections of the address lines as well as the data lines is over. Now we need to make out how to enable and disable these chips. First let us start with the latch. So why we require latch? First answer, so I've already told, again repeating. So port 0, it acts as both address line as well as the data line. So whenever we are making use of the data line, we cannot use the address line, and when we are using this as a address line, we cannot make use as a data line. So in order to differentiate between them, what we are going to do is, so first we place the address on this line which will be latched in the 8-bit latch. Then after this complete line will be available for the movement of the data. So the address is not going to make any effect for this one. So that's why we are going to use this latch. Now in order to enable to store the latch, so there is one exclusive pin available in 8051. So that is called address latch enable, which is an active low, so which will be connected to the latch here. So whenever a low is introduced in the timing of the ALE, so then the address will be latched, and further that address will be available to address either the RAM or the ROM based on the requirement. So latch, it's over. Now getting into the 16 kilobytes of RAM. We need to write into the RAM as well as we can read from the RAM. For both of these two, we require two exclusive lines, and let me have a connection to that one. So two exclusive lines. So one, I'm going to connect the write operation. So WR bar here and here also write operation. In order to read the data, I'm going to connect the read line for this one. RD bar, and here it is output enable, right? So ROM, it's over. Now getting into 32 kilobytes of ROM. So in order to enable and disable the data reading from the ROM, we are having one exclusive pin in 8051, that is PSEN. So I'm going to connect that PSEN line to this one. So it is PSEN. So this is active low. So this will be connected to output enable over here. So whenever PSEN plays a low signal, then this output, then the data reading from the ROM will be enabled. So this is all about the interfacing of 8051 with the external memory RAM as well as the ROM. So here there is a consideration that complete data is being read from the external memory only. That means the external memory starts from the memory location 0000H. So if we consider a continuation from the 8051's internal memory then to the external memory, then the address value is going to be little bit changed. So we are not doing that one. We are considering that we are reading completely from the external memory starting from the location 0000H. Thanks for joining.